Hey class, Miss Anderson here. Today I'm going to record the video on 1.3b, midpoint and distance formula. By the end of this, I hope that you can find the midpoint and distance between 2 points. Here's the first midpoint formula, and the midpoint formula is going to look a little strange right away. It's like x1s and x2s, y1s and y2s, but really what that's referring to is if you have a typical coordinate point like an xy point, and you have two of them, the way you can tell them apart is that this is the first point and then this is the second point. So you have a x1 and a y1 and then an x2 and a y2. So you have two x's and two y's. And you find the distance between them by adding the x's together and dividing by 2 and adding the y's together and dividing by 2. Consider two numbers just on a number line, for example, like 10 and 20. I could ask you what's halfway between 10 and 20, and you could easily tell me 15. And you can find that by taking, let's say this is your first point and this is your second point. So if you add them together, you get 30 and then divide by 2. Oops, I meant to put 10 plus 20 is 30 and then divide by 2 and you get 15. So you can find the distance between any two numbers by adding them together and dividing by 2. So that's, the halfway point between any two numbers. Make sure I say that correctly. So if you want the midpoint between any 2 points, you do that for both the x and the y coordinate, and you get the midpoint. It can also be used to find an endpoint. So let's practice that. So we have the 2 points, K and H, and we're going to say that this is our first point, so we're going to let that one be x1 and y1, and then this is our second point, so x2 and y2, and then the midpoint between those two, you are going to first find the x coordinate, so -9 plus 5, and divide that by 2. So I'm just using the x's there to find the x coordinate. And then to find the y coordinate, you're going to do y1 plus y2 divided by 2. And then evaluate that. So top first, -9 plus 5 is -4, divided by 2 is -2. And 3 plus 7 is 10, divided by 2 is 5. And so the midpoint between this K and H would be -2, 5, which means it's halfway between the 2 points. Or that would be the midpoint of the segment with those endpoints. All right, let's do this one. If our endpoints are -12, -7, we'll let that one be x1 and y1. And then this will be our second point, x2 and y2. And so we're going to find the x coordinate first, adding the x coordinates, the first two together and dividing by 2, -12 plus -8 divided by 2, and then -7 plus -4 and divided by 2. So after we're doing the y coordinates together. So -12 and -8 is -20, divided by 2 is -10. And -7 and -4 would be -11, divided by 2, which would be 5.5. So that would be my midpoint there. So now find the coordinates of the missing endpoint given that E is the midpoint of DF. So if we know the midpoint, we have to work backwards a little bit. So we have our 1 point, our x1 and y1, but we don't know what our other points are. So we have like 5 plus our other x divided by 2 equals 4, this one. Or we have 8 plus the other y divided by 2 equals 3. So I'm finding the two coordinates using, this was my midpoint because the midpoint gives you an xy coordinate. So this is my x and my y, and this is just my first x. So I'm solving for my second x. And then this was my first y, and I'm solving for my second y. So then you can solve these equations individually for x. So I would start by multiplying by 2. So you'd get 5 plus x equals 8. And you can solve that with mental math or continue the order inverse operations and get 3. So our other endpoint's going to be 3. And then solving this one over here, I got to move that over just a little bit for you. The same way, multiply by 2. And we get 8 plus y equals 6. And then minus 8, get y equals negative 2. And that's going to be your y coordinate for our midpoint, or our coordinate f from the segment DF. So for this one, we're given D, but we're not given F. And so we're going to go ahead and do the same thing. We're going to assume that this is our first x and our second, or our first x and our first y, and this is our midpoint. So when we take the first x plus our second x, which we don't know, and we divide by 2, we get negative, or we get positive 1, this x over here. That's what the endpoint equals. And then when we take negative 8, the y, plus the other y divided by 2, we get negative 2, this y. So negative 8 is our endpoint, plus our other endpoint, divide those by 2 equals our y coordinate of our midpoint. All right, and we're going to solve that the same way. So starting by multiplying by 2, we get negative 3 plus x equals 2. Then add 3, we get x equals 5. Same thing over here, multiply by 2. Negative 8 plus y equals negative 4. Then add 8, get y equals 4. So that means that our midpoint, which is coordinate f in this one, is the point 5, 4, because it's an x, y coordinate. All right, the next formula we're going to look at is the distance formula. So in the midpoint formula, we are looking at the 2 endpoints, and it is giving us the location of the midpoint. Versus the distance formula, we're going to have 2 points. So this is my first point, and this is my second point. And the distance formula gives me this length, the distance there. So because it's giving you a length and a distance, it's always going to be positive because it represents a distance. Like you ran 2 miles, you can't run a negative amount of miles. So a distance is positive. And then we want to leave the distances in simplest radical form unless I say otherwise. So let's practice with this distance formula. So L is going to be our first point. So L, x1 and y1. And then y is going to be our second point. So x2 and y2. And so first you're going to find the difference in the x's and then square it, plus the difference in the y's and square it. So we're going to do x2 minus x1. So distance is equal to, it's going to be the square root x2 minus x1 squared. And then you're going to do the y2 minus y1. That's going to be plus in the middle. And then that's 9 minus 0 squared. And then you're going to evaluate this carefully. So it's going to be the square root. 5 minus negative 7 is going to be the same thing as 5 plus 7, which is 12. So you're going to get 12 squared plus, I'll leave it in parentheses, 9 squared. And then you're going to take square root. 12 squared is going to give you 144. 9 squared is going to give you 81. And we're adding those together to get, I should have probably grabbed a calculator. I wonder if I have one on here. 144 and 81. It's not prepared. 225. That works out nicely because the square root of 225 is 15. So my distance between these 2 points is 15 units, whatever units that is. So 15 units long would be the distance there. Okay, let's try the distance between these 2 points. So this is going to be your first point, so x1, y1. Second point, x2, y2. Then the distance formula is the square root. You find the difference between the x's and square root, plus the distance between the y's and square root, the difference between the y's and square root. So it's going to be square root 4 minus 1 squared plus 2 minus 5 squared. 4 minus 1 is 3 squared. 2 minus 5 is negative 3 squared. And this is why I wanted to make sure to leave it in parentheses, because 3 squared means 3 times 3, which is 9. Negative 3 squared means negative 3 times negative 3, which is also 9. But if you type it in as negative 3 squared, your calculator will do 3 squared and then apply the negative, so it will give you the wrong answer. So be careful to make sure to put it in with the parentheses or use your brain. Then 9 plus 9 is 18. Then I wanted it in simplest radical form, so I know that 18 can be broken down into 9 and 2, or 3 and 3. So the square root of 9 is 3. So square root of 18 can be broken down like that, so I can take out a 3, or the square root of 9 is 3, and you have the square root of 2 left over. So we have the square root, 3 square roots of 2 units for that. And if you think about the square root of 16 is 4, then the square root of 18 is probably approximately 4.2 units long. So that's our distance, but we do want to leave it in square root. I like this example that gives you the points L and M on the coordinate grid, because I like that it shows you where the distance formula comes from. So we're looking for the distance between L and M. Now, if you look at dropping down that straight and then drawing this over straight, we have what's called a right triangle. Now, L is at the point negative 1, 2, 3, 4, 5, negative 5, negative 1. And M is at the point 2, 3. Now, if you use those coordinates and you find x1, y1, x2, y2, so you do x2 minus x1 squared plus y2, so 3 minus y1 squared. So you're going to have 2 minus negative 5, which is going to make that positive 5. So you're going to have 2 plus 5, which is going to be 7 squared. And 3 plus 1, which is going to be 4 squared. Now, if you count the distance here, 1, 2, 3, 4, 5, 6, 7, notice that that gives you 7. And that's the difference in the x coordinates. x2 minus x1 is going to give you that length between the x's. And then if you count this distance, 1, 2, 3, 4, you'll notice that when we did y2 minus y1, y2 minus y1, we were given this length. And if you think back to a squared plus b squared equals c squared, it would be 7 squared plus 4 squared equals c squared. And then to get c by itself, you would have to take the square root of both sides. And ta-da, you have the distance formula, which is also how you find the hypotenuse of a right triangle. So that is where the distance formula comes from. So we'll finish solving this. You're going to get the square root of 49 plus 16, and 49 plus 16 is going to give me